This video will show you a quick review over naming formulas for ionic compounds that contain polyatomic ions. So remember, ionic is made up of a metal and a nonmetal. If it contains a polyatomic ion, that means that the formula is going to have more than two elements because polyatomic ions contain more than one element. You can find your polyatomic ions by using your periodic table of ions, and they are in this box right up at the top. So that's where you will find most of the formulas and the charges for those polyatomic ions. Okay, here are a few examples. Now, if you notice, before we even start, the names, whoops, that one's an exception. The names for polyatomic ions will usually end in ate or ite. So if you look and the last part of the name ends in ate or ite, it is going to be a polyatomic ion, which would be up here. Now, there are a few exceptions like hydroxide and cyanide. Those are a few that are polyatomic ions, but they do end in ide. Normally, polyatomic ions would end in ate or ite, and regular binary ions would end in ide. So that is something to pay attention to right off the bat. All right, since these are ionic, you still have to balance out the positive and the negative charges. So strontium has a +2 charge. Chlorate, if you look in the polyatomic ion chart, chlorate is ClO3, but that whole group of atoms has a -1 charge. So chlorate has -1, strontium is +2. So looking at the charges, we are going to need 2 chlorates for every 1 sodium. So if you need more than one polyatomic ion, this is where you have to use parentheses. Since chlorate is ClO3, that formula cannot change. It has to stay ClO3, but if you need more than one, you would put the number that you need outside of the parentheses. And just like in math, whatever number is outside the parentheses is going to apply to everything within the parentheses. All right, next example, calcium is +2. Hydroxide, whoops, 2 didn't look very nice. Hydroxide is OH and it has a -1 charge. So this will be very similar to the first example. To make the charges equal, we need a total of 2 hydroxides. So again, since hydroxide is a polyatomic ion, we are going to put the OH in parentheses and put the 2 on the outside of it. The third example, potassium nitrate. So potassium is +1. Nitrate is going to be up here in the middle column, which is -1. So we have +1, -1. The charges are already equal. So then we only need 1 potassium and 1 nitrate for that formula to work. All right, the last two contain transition elements because the cation has more than one charge, which is why we have a Roman numeral in the name. So if the name is cobalt-3, remember that 3 means that cobalt is +3. And then we would find phosphate. Phosphate is up here. The formula is PO4, and as a whole, that has a -3 charge. So since cobalt is +3, phosphate is -3, then we would just need 1 cobalt and 1 phosphate. But remember, to include phosphate, you have to include all of PO4 because that is phosphate. If you change the PO4 or if you take off the 4, now you've changed the formula completely, which means it would not be correct. All right, the last one, lead-2. Again, since it has that Roman numeral of 2, that means that lead would have a +2 charge. Nitrite, so you have to be careful because we have nitrite and nitrate. Nitrite is NO2, and it has a -1 charge. So lead is +2, nitrite is -1, so we're going to need 2 nitrites for the formula. And again, since nitrite is a polyatomic ion, we're going to put NO2 in parentheses and then the 2 on the outside to show that we need 2 of that entire polyatomic ion.